Welcome to Energy Frontier, the Wyoming Landscape podcast. Hosted by Dr. Holly Krutka, Executive Director of the School of Energy Resources at the University of Wyoming. The show highlights SER's role supporting our mission to promote energy-driven economic development for the state of Wyoming.
Welcome back, listeners. Today we have two guests who operate at the heart of materials innovation, energy systems, and the critical minerals challenge that the nation's facing, and also here that we're working on here in the state of Wyoming. So Anthony Nickens is Division Director of Materials and Manufacturing at Idaho National Lab. He oversees efforts to push and new processing technologies for critical minerals, scale emerging materials, and he and his team partner really well with universities, industries, and other national labs, and they're really a leader in many of these areas, and they're great at partnering, including with us here at the School of Energy Resources. Our other guest today is Travis McLean. He is INL's Chief Geologist and Directorate Fellow at Idaho National Lab. He leads our geothermal efforts, and he plays a key role in geoscience related to critical minerals research and development. And he's been working with us at the School of Energy Resources, and actually I think was an adjunct faculty member at one point.
Yes.
Okay, for a long time. So great partnership over the years, and really appreciate you both being here.
It's a pleasure. Thank you.
It's great to be here, Holly.
So let's start with you, Anthony.
Sure.
You've had a really exciting and fascinating career path. So from the Navy to industry, now you're leading a major division at Idaho National Lab. So first of all, can you just walk through your career and talk about key moments or decisions that shaped your trajectory?
Sure. Well, I grew up in the South, so I grew up on a tobacco farm. So I started working in tobacco when I was 8. And my dad said, son, if you don't get a college education, you're coming back in these tobacco fields. I said, Dad, I'm not coming back. So that taught me the value of hard work. And man, I had to save up to go to college. So my parents didn't have the means to send me to college, so I had to save up and work in tobacco. So went to NC State and got my degree in chemical engineering, bachelor's. Then I kept studying hard. Then I went to University of Florida to get my master's in chemical engineering there. And then I was 22. I didn't want to go back to a small town. I wanted to go back to a big city to meet girls. That was it, Holly. That was it. So I landed up in Washington, D.C., started working for the Navy there, joined the Navy Reserves as well. Worked in the federal government till went to the Office of Naval Research. Then I got bored. Throughout my career, I want to go somewhere where you got to get outside of your comfort zone, because that's how you're going to learn. Mm-hmm. So I went from federal government to private industry and was the vice president of a company called Ceramatech in Salt Lake City. Boy, that was outside my comfort zone. Did that for 10 years, led some bunch of great research and scientists and technicians there, learned a lot about proposal development and all of that. Then I got bored again, and I wanted to do something different to get outside my comfort zone. Then I joined the Idaho National Laboratory back in 2017. And in parallel to all that, I did 30 years career in the Navy Reserves, retired as a Navy captain. I had 7 commands in the Navy as well. So, but for the young researchers that are listening, you got to get outside your comfort zone to really learn and expose you to new experiences, and you'll be a more valuable member to your organization having those past experiences. So.
Yeah, I totally agree. I think we had someone on the podcast who said it really well, that they never regretted the risks they took, even the ones that failed.
Right.
They regretted the ones they didn't.
Correct.
The things they didn't do.
Correct.
So, okay, Travis, how about you? Talk about how you got to your current position.
Thanks for the question. And it's been an interesting career path for me. I grew up in South Central Montana, kind of a kid of the sagebrush, and knew I wanted to spend my life doing something that was outside. Working in an office wasn't a particularly appealing career path for me. I had gone and done some volunteer service for a couple of years, and while I was gone, my sister had signed me up for classes at university, and one of those classes was a geology class.
Did you know she was doing that?
Yeah, I'd asked her to do it because I wasn't available. I was not able. Back in those days, you couldn't do things remotely. It had
Got
been
it.
on person.
Okay.
And so I took a Geology 101 class, and I remember just being gobsmacked when I sat in that class and started listening to the geologic processes and how the earth was put together and things that I had seen walking around in the mountains of Montana and Wyoming for my youth. I remember walking up to the professor after about the second week, and I said, how does one get a job doing this? And he took me under his wing, and I became his field assistant. And I knew from that moment on, from that Geology 101 class, I wanted to be a geologist. And in the early 1990s, I graduated high school in the mid-'80s, and I had a trajectory. I wanted to go on to be a mining geologist. That was what I wanted to do, is work on ore deposits. But by the time I finished up my bachelor's degree, metal prices were in the pits.
Yeah.
And there weren't any job opportunities of any consequence. I had a young family, and I began looking at how I could utilize the skill sets I'd learned in my undergrad program. Decided to go do a master's program to buy myself a little time. Worked with a professor named Mike McCurry at Idaho State University, and I said, I've got a family, I need some money, I'd like to see if there are any internships or summer work programs. He said, well, I know a guy at Idaho National Laboratory. Made a phone call up and said, hey, I've got this young, clever geologist. He'd like to learn more about the work you guys do. And I went and did an internship, got connected with my mentor. This man ended up being my master's and PhD advisor, ended up hiring me, and that was back in 1992. And so I've been at Idaho National Laboratory since then. I took the skill sets of a mine geologist and applied them to cleaning up metal contamination and mine cleanup for about 15 years, moved into carbon sequestration, geothermal, and I'm now leading the upstream side of the critical minerals research at Idaho National Laboratory. So it was quite by accident, but very purposeful. Once I found out that you could earn a living looking at rocks, I was hooked, and the rest is history. It's been a fine career.
Not too different from the story of a lot of people here at SCR. We have a lot of geologists who would tell a story like that.
Excellent.
So the way we're going to do this podcast is we're going to kind of divide it up. So Anthony, I'm going to focus on you and your team and kind of the areas that you're focused on. And then Travis will talk about kind of applications to Wyoming. But of course, either of you jump in. So Anthony, we're going to start with you. So talk about your current role as division director at INL.
My current role, I lead a group of about 138 research staff, as well as technicians as well. And we do cutting-edge research in the areas of bioenergy research. Critical materials research is in my division as well, both on the geoscience side and then the separation side as well as we do a lot of material development work, especially materials for harsh environments, very harsh environments, and advanced manufacturing. So we are doing that, and the business is growing. So, that's my job. My job is to kind of inspire them, to help them, mentor them. If the process is kind of bogging them down, whether it's contracts or agreement, I get involved to kind of unlock that, and also make sure they're paid, Holly, which is important.
Good idea. Works better that way. So talk about just at a high level, some of the big scientific or engineering challenges that your team is tackling today.
Well, on the material side, our specialty is materials for harsh environments. Looking at where the needs are, especially developing materials that can go up to like 900 degrees C and operate in a very corrosive environment and a high radiation environment. And we're working on like a compact heat exchangers for that now, where you have embedded sensors that can measure the flow rates, that can measure how well that material is doing over time, and have it exposed to those very harsh environments. So that's cutting edge, and it's a real need for the nation, so for the advanced reactors and other applications that are out there. So that's an area. Critical materials is another big area, a growth area for us, both in the geosciences side, and Travis can talk about that, and in the separation side. We've been involved with separation for a long time, got some core competencies there, and it's just exciting time because the nation needs new technologies to be out there to bring home that manufacturing here in the United States. So it's good. So
sure. And it's such a timely topic with everything happening geopolitically. So I want to talk more about your division, but one of the topics we also cover on this podcast is leadership.
Sure.
And so I did want to ask you a question about that, because you have a background in the Navy and in private industry, right, and now at the nation's Nuclear Energy National Lab at INL. And so you've led like very, very different teams. And can you talk about your leadership style and how it's evolved, and how like anything that you felt like consistently was effective, or how did you approach leading different teams like that?
Well, when I looked at my Navy career, 7 commands, and in my civilian career leading, there's some fundamental basics that to be a good leader that you really need to employ. And I believe in the old adage of be quick to listen, be slow to speak, and slow to anger. I mean, listening is a superpower. To be able to listen to other people, to be able to listen to people who may have different thoughts than you, which is even more valuable, to bring in those people whom you need a different thought or a different perspective. Hey, you know what? Their idea may be better than your idea. Well, put your ego aside. I'm going with their idea.
Yeah.
You know, it's just a matter of integrity, showing teamwork. We're all a team. And having that outward mindset where, you know, if you work for me, Holly, I'd be going, well, I wake up in the morning, how can I make Holly excel today? What barriers does she need to overcome? And have that mindset every day. And you do the same thing in the Navy. A lot of the stuff in the military, you got a lot of time to make decisions. Sometimes you don't, but a lot of time you do. But you need to have that and have a sense of humility. I mean, and check your ego at the door. I mean, you know, be able to do that and wake up and inspire and help and mentor these researchers. And so that's been my leadership style. Pretty open book. If any staff wants to talk to me at any time, they know to talk to my admin, and I'll meet with them on anything. So that's it. I mean, I think the power of listening and just having integrity in everything that you do. So,
okay, say that one more time. Slow. Okay, quick to listen.
Quick to listen. Slow to speak, slow to anger.
I love that. And
listening is a superpower. That's another thing.
Got it. Wonderful. And that leadership translates obviously into success over time. And you have this incredible team that is focused on all these topics like advanced materials recovery, including critical minerals. So talk about what excites you and your team most about working in this space.
I think one thing that really gets you is that the nation needs us. I mean, the nation needs not only INL, but the broader academia community, industry. The nation needs us now more than ever. I mean, very rarely do you get a president of the United States doing rare earth deals everywhere he goes.
Yeah.
You got the administration focused on that, and the whole of government is focused on, and our lab is focused on that as well, building capability in our lab and really strengthening partnerships that we have. So it's very exciting times now, especially in that area.
Yeah, and it also ties in to national security and energy independence. And can you talk about that? How do you kind of motivate your team to see the big picture and how these specific projects really support our nation? Yeah,
well, Idaho National Lab, part of our DNA is supporting the national security, if you will.
Right.
You know, we built tank armor at the Idaho National Lab. We have core competencies in next generation protection systems. That's a core competency of ours. And we do a lot of national security work. So, you know, that's nothing new to Idaho National Lab. That's a growing percentage of what we do, because our nation needs that Pacific expertise. And our folks are really motivated. They're great Americans. They want to help the nation. And we do a lot of stuff that nobody will ever know about, and there's a good reason. But it's very impactful for our nation, and I'm proud to work there.
As you should be. So, I know you can't talk about everything that happens at INL, but can you talk about some of the specific projects that your team's working on?
Yeah, I mean, one project in particular, which is a difficult one, it goes back to materials for harsh environments, building or coming up with new materials that can withstand those harsh environments. And we have one program. We have the world's largest experimental electric field assisted sintering machine. So these are machines that can really densify hard to densify materials. Now, these materials have been out there, but it was very uneconomical to build bigger shapes of these because of the cost. Well, now with this technology, we have an 800-ton press. We can have up to 150,000 amps at low voltage. We can sinter very hard to sinter materials, which now opens up. Okay, you want something to go really high velocity that can withstand that. New generation of tank armor, or new generation of just armor in general. It doesn't have to be tanks, but now that just opens up that avenue, and we're starting to get a lot more interest in that area. But that's very exciting, and the technology has been around for 30 years, but it's all been to benchtop, and now we can scale it, and very, very exciting. We got quite a lot of industry interest in there as well for carbon composites, silicon carbide composites, and boron suboxide and different things. So
that is really cool.
Exciting times, Holly.
Anthony, do you mind if I talk about another one of our specific capabilities? And it's built on this. A lot of things that we can do in our critical and strategic minerals portfolio for the nation. You can accomplish a lot of work on a bench scale, but things are a lot easier to do at bench scale, recover a gram or a microgram of some particular element. But to actually test that, and as Anthony talked about in his previously, is doing things at pilot scale, at bigger scale is really important. And that we've built Anthony's team and Idaho National Laboratory in our initiative, we have built the capability to do the metal extraction and separations from ore materials at a ton per day kind of scale to run for months and months at a time. So we're starting to approach that area where we're getting into the industrial impact. Can you do things at a relevant scale that informs industrial processes? And we'll be doing the first in the nation recovery of antimony from a mine site in Idaho to provide the military with the antimony they need for their munitions. And that's really putting together all of the key components that one needs to be able to run a process for a period of time and deal with some of the ancillary effects. And they talk about harsh environments. Geology systems are harsh environments.
You got that right.
Antimony, it doesn't just come with antimony. It comes with other components too. Sometimes they're norm materials, naturally occurring radioactive materials. Some of them are cadmium and mercury and other selenium. And so we are doing the work at Idaho National Laboratory that can't be done elsewhere or shouldn't be done elsewhere, and be able to prove the concept so that folks can take that technology and then valorize the process and do the work at INL. So we're doing work on materials, but we're also doing work on raw products. So we will take raw materials and test and refine that recovery process so that the military can get that valuable product. And we have industries lined up to bring their feedstocks to that testing facility at Idaho National Laboratory.
That's a perfect segue, because I was going to ask about the Metallic Initiative, which my understanding is kind of the collaboration of national labs in the rare earths and critical minerals space. And this is why INL is one of the reasons INL's expertise and partnership and leadership in that program is so important, is because you can do things like being a nuclear lab, like that separations and processing that other national labs that aren't nuclear labs can't handle that radioactive material. So for our listeners, explain the Metallic Initiative and what INL's role is.
Okay. The Metallic Initiative started almost a year ago, came as is funded by DOE Fossil Energy. Basically, it's a consortium of 9 national labs. INL's one of those national labs. Is headed up by the National Energy Technology Laboratory. And Metallic is really focused on materials or minerals to materials supply chain research facility. So it's a combination of capabilities that the national labs offer to really solve some of the technology challenges, and also transition technology to industry, to work alongside the industry. And they're mainly focused on pilot kind of projects. So taking things out of the lower technology readiness levels, and how do you scale those up, and how do you verify and demonstrate those, and how do you bring industry along with you so they can take the technology forward, but just bringing some of the core national labs together working on that.
That's great.
Yeah, and the Metallic program has really enabled us to invest in capabilities that we didn't have before. So the first tranche of funding that came out was to buy equipment necessary to do the kind of advanced research needed to start the process of becoming domestically secure in critical and strategic minerals. The next part of the project are what are called signature projects, which are aimed at utilizing that infrastructure to then get that information out and partner with the industry and academic community. So we're building capabilities in the laboratory. We're buying new, really sexy equipment that we can work with. And then for that equipment, we're actually building, we have the seed projects or signature projects that allow us to engage industry and work on that equipment. So it's really, it's a night, you don't see that typically in Department of Energy funding where they're able to bring resources, hard resources to bear on problems, and then fund the problems that enable the utilization of those tools. So it's been a really unique experience for us, and to work with our other national lab partners.
Great. So You're already talking about it around rare earths and critical minerals. Talk about what role do pilot plants and test beds and scale-up facilities play in bridging the valley of death and innovation, and why our national labs, and sometimes I would say we also do this here at the School of Energy Resources, like why are we that level of research? Why is it the right place to do at like kind of these public facilities?
Yeah,
I think I'll go first, Travis.
Yes, sir.
But building pilot plants are essential to de-risking the technology.
Right.
You can have a technology at the bench scale, but industry wants to know, how do you scale it up, and can you make money?
Right.
What's the economics of it? So you've got to scale it up, and some things may not scale. So you learn fast and you move on. Then your other pilot plants, you want to demonstrate it, verify it, take the lessons learned to tweak it to make it better. So ultimately, you've de-risked it enough so that CEOs of industry can write to checks to build a full cell system and get the technology. But that's where the applied labs and some of the academia fits in that area. But it's key. It's key. Travis, thoughts?
Oh yeah, it really is. It's the piece that's been missing from my career for 34 years. You find a lot of research funding agencies willing to pay for the bench scale because it's really economic.
Oh yeah.
But to go to that transition into something where you're working with a ton of material every day or 5 tons of material every day is difficult. A really good model for that, and I use it all the time, is we knew for as long as we've known these formations exist, tight shale formations were loaded with hydrocarbons, gas and oil. It wasn't until the federal government came in and partnered and de-risked that from a financial point of view and proved the directional drilling, proved that fracking could take place, that it actually took off. Industry was able to pick it up, and now it's the cornerstone of the oil and gas industry across the world. The same thing in our critical and strategic minerals portfolios is mining companies some of the companies, even the very large companies, as a whole, mining companies invest less in research and development, about 0.5%, than any other major industry in the world. Meaning that they're very good at what they do. They're very focused on the recovery of the metals that they mine, but adopting and developing new technology that are step changes are something that needs to be de-risked because it isn't something that they typically have the capital to invest in. So these public-private partnerships that enable us to go out and test things at scale that can then, and as Anthony said before, getting across that valley of death, de-risking it, getting it up to a TRL 7 and 8 position, where then industry says, well, that is something that we really can do. And the reality is that it has to be done because in the United States, we have to produce metals at a globally competitive price.
Right.
We don't have the luxury of paying 10 times more for metals just because they come from an environmentally safer means in the United States because we still have China to compete with. So we have to do it better, and we have to do it more economically. And the only way to do that is to prove that you can do it at a scale that is reasonable. So some of these pilots that we're talking about, we're going to run for 5 or 6 months. We'll run every single working day for 5 or 6 months. We will look at the process. We'll look at the recovery efficiency. We'll go back in and we'll refine. We'll tweak. We'll go back. And as at Idaho National Laboratory, we don't pick winners and losers. But we are as an honest broker. And this is the same kind of position that University of Wyoming has been in for a long time, which is demonstrating honest data and results so that industry can adopt and make decisions based on that. And so that's really, I think that's the value proposition. And it's a place where there just isn't a niche in the private sector that does this.
Good point.
I think the other thing that I would add is that both INL and the School of Energy Resources were mission driven, right?
Yes.
And so you can see how even at the earlier stages of development, this technology could serve the nation, and getting it past that pilot scale is like part of making it a reality.
Absolutely.
Right?
Absolutely.
You're not just trying to write papers, and that's the same for us too. It's like SCR is here to serve the state, and I don't know how the things we're working on could do that if we don't get them down the road of getting scaled up until industry feels like, okay, we can run the economics on this.
Because you've de-risked it.
Yeah.
Right? So absolutely.
Especially in systems where there's physical processes that have to be done.
Exactly.
You can beta test a software package.
Right.
And you can do it relatively inexpensively. But recover 230 ppm of gallium from a zinc feedstock, that's tough.
Yeah. We're talking about hard tech right now.
Yes, we are. Exactly.
So talk about, you've already touched on this a bit, but can you talk about how do you approach coordination across different stakeholders, so industry, academia, government, and how do you make that collaboration succeed?
I think first you have to have a mission. Especially if you're working in a consortium like Metallic or others, what's the mission and what's the value proposition of us collectively working together? And what's the sense of the governance? How's the governance? Who's going to be responsible for what? How is it organized? How are we going to communicate together back and forth? Who's going to be responsible for what? And the underlying that keeps that engagement of that consortium together is trust among partners. That is key, and it's trust that you've got to build up over time, but that's the underlying thing that keeps consortium together. And what's the common mission to purpose that satisfies both industry, national labs, academia, government policymakers? But I think that those are the fundamentals that you really have to have in place.
I think building on Anthony, I'll focus a little more finely on that. Is those partnerships are really important. If funding opportunities and other research opportunities appear, if you haven't established a relationship with your partners, you're really behind the curve, and you may not ever be even successful at getting a proposal out. To that point, establishing the relationship with those partners is really one of the reasons why the universities in our region are so very important to us. And we can come and talk to you, Holly, and the Rolodex of industries, of trusted partners that you have, that you currently work with, is huge. And national labs, we have some of those in our back pocket, but not nearly as many. If I want to work in Wyoming, I better be working with the University of Wyoming and SCR to have entree into those industry partners, because to say you're here from the government and going to help is really not a good starting point. So by working with your staff and working with collaborators, whether it's in Utah or Montana or Nevada or here in Wyoming, which we've had very successful over the years, is you come hand in hand and you develop that relationship. And part of that is that because we're so very close to the federal government and not being part of the government, is that we can translate what they're asking for, what the program managers are willing to fund, to the institutions and to industry, and try to bridge that gap of understanding so that we can tweak our skill sets to provide what the customer needs. And in some fashion, we also are able to help the funding agencies understand what is needed. And I think that's part of this. INL does some things incredibly well, but we don't do everything well. And universities and industry are the key component, the second and third legs of that stool that enable us to go forward and accomplish our mission.
And we look at it as people, facilities, and partnerships to make it happen.
Great. Well, Travis, I want to come back to you because you've been working with the School of Energy Resources in your role at INL for a long time around a lot of different topics, including geologic expertise for rare earths and critical minerals. Obviously, it's much broader than that. Where do you see that collaboration going in the future?
I think it's an interesting question, given that we're in the midst of a government shutdown and trying to figure out where the dust settles and how it goes forward. The reality is that in the federal coffers, there's a significant amount of money directed towards high impact research to bring solutions to our critical and strategic minerals problems, including rare earths. We have been 30 plus years creating this problem. Now we're only given a few short years in comparison to try to solve that problem. So what it means is that we are going to be able to take those relationships and the skill sets that you have. And I'll just backtrack just slightly here and say that even in the hiring research staff to fill positions needed to address these problems, when I go to meetings or I meet with students or professors, I meet with the same people over and over again. We are not producing the students, the researchers, even the miners needed to fill the void to begin to address these problems. So I've learned over the past few years that I cannot build a free agent team. That is, I cannot go out and hire enough people to fill the needs that I have to support my research efforts. I have to build the farm team, which means that starts with internships, that starts with graduate students, funding them, getting them through their programs, and hopefully enticing them to come work at the national lab or even work in the general ecosystem. It's all right if they go out and work with the industry. It's fine, but we need to build that. And the only way to do that, we cannot generate that kind of flow of human capital into the mining and geothermal field. We have to do that through partnering with the university, and that's funding research that enables those students to get those degrees they need, or even workforce training to enable them to come out and work for us at a national lab in a research space, to go on to become professors to teach students. But it's that network, and we're just at the very beginning part of being able to address that problem. But we are short hundreds of thousands of skilled workers and researchers to even begin to address the problems that we have. We'll be short 250,000 miners by 2035. So that's just in existing, a 250,000 workforce we're going to lose just due to retirement. So that doesn't count the economic geologists, the ore deposit geologists, the mineralogists, the separation chemists, the miners, the truck drivers. So we've got a big problem if we're going to bring this new industry to Wyoming, to Idaho, to Utah, to the United States. We got to find the bodies to bring in there. And I think the best way, if you can train and hire students out of Wyoming to work in Wyoming mines, they stay in Wyoming. If you hire them out of the West Coast or out of Brooklyn, they want to go back home.
Oh, yeah. Very different. I will say, I totally agree. We're working really hard to build up our capacity here at the University of Wyoming. And one of the things the School of Energy Resources does is hire faculty to be in other departments that have these core skill sets that are important for the state. And one of them that we've already hired, and we have another ongoing search, is around the rare earths, critical minerals, just really separations. That's going to be their focus. But, separations obviously is a big field. Yeah. But it's tough. Mm-hmm. Like, to get two people here is going to take us a couple of years. It is so tight out there. And so I'm hopefully, though, as they get here, they get students, those students enter the workforce. Some of them will work at INL. Actually, I think I'll just give a little shout out to Chloe.
She's a rock star.
She is. And she's, UW PhD grad. She worked for Caleb Hill over in chemistry. And then not the last time, but the time before I was at INL, she had a poster, and she's working on this very topic, right?
Yeah, she is.
Yeah.
And we've made her an honorary geologist. She works with my team on a daily basis. So she's teaching my rock lickers what separation chemistry is all about.
Though, right?
Yep. And then we bring her over here and let her play with rocks and understand why separation chemistry is difficult or different for these type of rocks. Mm-hmm. So she's routinely walking up and down our hall. I'll give a shout out for Chloe. She's
definitely a rock star.
Phenomenal. Yeah. We need a dozen Chloes.
Okay, well, we're working on it.
Excellent.
That's University of Wyoming graduates there for you. So talk about, Travis, from what you've seen, what advantages or constraints would Wyoming have for bringing critical minerals or advanced manufacturing projects here to the state?
Thanks, Holly. I've had an opportunity to listen to some of your state and congressional and legislative delegations. I've listened to your federal delegations. I've had a chance to listen to the governor speak, and the desire to do the right thing by Wyoming and to kind of break the paradigm of shipping out low-value products, bearing the environmental costs associated with mineral extraction and sending it off where they turn it into very high value products. Is I think some of those challenges that Wyoming faces is workforce diversity in terms of skill sets, and to be able to take what you mine in the state of Wyoming and be able to turn it into a high value product to maximize the type of revenue you have, and then send it out to industry to enable them to then accomplish their goals. We should do things in Wyoming rather than do in Indiana, as opposed, so that we really benefit that value chain. Other parts of that problem really are that we have a challenge ahead of us, and with respect to the geology. It takes, if we could wave a magic wand and you could have a permit in hand, and let's say that you were able to wave another magic wand and you could raise the necessary capital to open a new mine, you're still looking at 7 to 10 years to get a greenfield mine open, because you've got to move a lot of material.
Yeah.
You've got to build roads, you've got to build power lines, you've got to build infrastructure, you've got to build environmental containment and compliance structures. So it's a really difficult proposition that really is, because my children are in their 30s now. I say it's that the opportunity of my grandchildren are these greenfield new mines that open up. Some of them are more nimble and can be open, but broadly speaking, so that's a challenge, right? And being able to streamline that process and getting wheels on the ground quicker. But I think I'll flip that a little bit and say there's optimism too, is that you have existing mining operations that contain many or most of the minerals that we need to sustain the United States industry. So going to brownfield sites and taking technology to existing mines instead of recovering a single metal or a couple of metals, that where you can recover a whole value stream of metals from either their existing circuits or from the waste piles. A paper was published out of Colorado School of Mines not too long ago, and by Elizabeth Hawley and her team is talking that we have everything we need in the United States to meet our metal needs sitting in the waste that we would have called waste piles yesterday. They're not waste piles, they're opportunities. So I'll say there's challenges. Opportunity piles, absolutely. So we can both de-risk them by removing the metals that have been a concern from a regulatory point of view, and we can put those into the marketplace, and we can stabilize and then replant, vegetate, and reclaim those tails for future use.
So Anthony, I think we know we have a lot of opportunity in Wyoming and the region and the nation. Obviously, we're focused on Wyoming. But can you talk about how are we going to realize that opportunity? Where do we fit in? Where does our collaboration with INL fit in? And what can we do to make this happen?
I think it all starts with partnerships, and trust in partners, and realizing that no organization or institution can do it all. And really recognizing our strengths and our weaknesses, and other organizations that has our weaknesses but is their strength, and working together, especially at the leadership level of both organizations. And then collectively, we have our partnership. Then how can we expand our partnership to other industries and really show a pathway to getting those technologies out the door? But it all, underlying that is trust in the organizations, and really knowing that the nation has a problem, and let's just get after it. So,
I love that.
If you'll allow me to add a little bit to what Anthony said, I use an example with my children. So they grew up with a dad who worked on cleaning up what we call the sins of the past. So I did that for 25 plus years. I worked on cleaning up contaminated sites, worked on mine sites that were national priorities and had significant environmental consequences associated with their operation. And now we're flipping the script. So I raised a whole generation of children that thought we were in the cleanup side of things, that we were closing this stuff down and we weren't doing these kind of things anymore. Well, and now we flip the script and say, now, well, we've got to source these materials within our nation or within our very close friends. And the population hasn't really made that change yet. And so I think these trusted partnerships are part of that story. Is if just INL says, well, we need to mine these materials and become domestically secure, it's a message that resonates within a very narrow population. If universities and policymakers are saying the same thing, we really have to change that paradigm, is that the minds of 150 years ago are not the minds of today. And that really every single person that relies on technology today, you're either getting it from a young person in the DRC that has no choice and can't go to school because they have to be part of the mining ecosystem, and or you're getting it through China, which at any time, and we're seeing this on a monthly basis, where they continue to restrict the exports of materials. We need to have what's happened in the nuclear field. In 2012 or whenever Fukushima was, I thought nuclear energy was dead forever. Little did I know the demand for electricity to drive technology would make people reconsider that nuclear energy really was the best option, or one of the best options, to drive future energy needs. We also need that kind of paradigm change when it comes to critical and strategic minerals. Is that the population needs to, our citizens need to understand that there's a hole in the ground somewhere that your technology is coming from. We do it better, we do it cleaner, we do it more efficiently here. And safer. And
Correct.
we don't have poor children in third world countries that are being exploited to make our technology. And I think that's both something that we require from an industrial point of view, and it's something from a social context point of view. And I'm still waiting for that groundswell, for that change of position where people recognize, well, somewhere there's a hole and we're going to have to do it, but let's do it right.
I also want to add to that, technology can only get you so far. For the nation, it takes a whole of government approach, from the statutes that the Department of Commerce has, for the Department of Treasury has, the Department of Energy can do the research, even Department of Defense is areas, in Environmental Protection Agency, the Bureau of Land Management. It takes all of government working together with their individual authorities to move the needle, to get America independent from having to go to China for rare earths or other countries that may not be our friends. I mean, we shouldn't be in this situation, but it does take a whole of government approach.
So well said to both of you. I think Wyoming and us here at the School of Energy Resources, we're in it to win it.
Absolutely.
And we're going to collaborate with you and try to reshore these industries and we'll do everything we can to focus on what can be done here in Wyoming.
Wonderful.
So you have a willing partner. So
fantastic.
While neither of you live here in the state of Wyoming, obviously you've both visited and you're right next door in beautiful Idaho. The last question of our podcast episodes is always one that focuses on how lucky we are to live here in Wyoming. And so we always ask our guests, what's your favorite place to visit in the state? So Anthony, let's start with you.
My favorite is Jackson Hole. I remember skiing.
And you're not too far.
I'm not. I remember skiing Jackson Hole, but I learned to ski late in life. I married a Montana girl who skis gracefully. So we skied in around Washington, D.C. Those are like 2,000 feet, you know. Then I had a trip out west to Idaho National Lab when I worked for the Office of Naval Research. I was going to go ski, and I was so pumped up. And my Montana wife said, okay, you better bring your A game to Jackson Hole.
Yeah.
Boy, was she right. I thought I was kind of cocky. I'm in the Navy. Like, dude, I got this, you know. I went on like the first Blue Hill and going, I don't have this. I mean, this is like big time.
Yeah.
But just the beauty of that area as well. And they got some great golf courses too. As a golf addict myself, they got some great golf courses. But Jackson Hole by far, so far. So.
Okay. Travis?
I'm going to move a little bit further east than that. Had the privilege of working for a number of years doing glacial research in the Wind Rivers, looking at atmospheric inputs to glaciers that we could then use to look at how to model groundwater systems. So my favorite place still to this day is Pinedale, Wyoming. It's a toss-up. I've done a lot of work on the Yellowstone hotspot as well, and the Bighorn Basin. But if you gave me a week to go anywhere, it's back to the Wind Rivers.
Nice. Okay. Well, thank you both.
Thank you, Holly.
So much
really
for all you do for the nation.
Thank you
for Wyoming, and thanks for doing the podcast.
Thank you, Holly, for your time.
Thank you for listening to this episode of Energy Frontier, the Wyoming Landscape, the podcast that highlights the School of Energy Resources at the University of Wyoming. You can expect a new episode of Energy Frontier every other Wednesday on Apple Podcasts, Spotify, or wherever you listen to podcasts. See you next time.